Welcome. In this lesson we're going to talk about mole percent, formula to batch calculations, finding frits by chemistry, using material XML, Na2O sourcing, handling oxide oversupply, added status in recipe lines, overriding in the supply dialog, rationalizing when to compromise an exact match, and thinking on the mineral level. Special purpose glazes can present interesting challenges in formula to batch calculations, as you can run into dead ends where it's impossible to match a formula using materials at hand. Often their oxide proportions are contrary to what is normally found in natural materials, and even frits. On page 41 of Richard Epler's book, Glazes and Glass Coatings, there is a chart of special purpose glazes like this. Richard speaks the language of mole percent formulas. Insight can do this also. Notice it in the calculation type menu. Here's an example of the same glaze shown as a unity formula on the left and mole percent on the right. A formula adjusted to mole percent simply recalculates the formula to total 100. Note that Richard also prefers to express each number as a part of 1, thus 0.5795 instead of 57.95. I'll work with glaze B69. I've closed both recipes in Insight and selected mole percent for recipe 1 and RO unity for recipe 2. Then I selected recipe 1 and chose Enter Formula in the Calc menu to display this dialog, and I've filled in the numbers. You might object saying that this dialog is intended for unity formulas, but actually it'll accept any formula. It doesn't care if it's been retotaled or unified. I'll click Done. Insight converts the formula into an analysis and inserts it into the recipe list like this. This looks good, but there's a problem. I entered CaO as BaO. I'll fix it. Notice that when I enter the formula dialog again, Insight has remembered all the numbers. It will remember these even between sessions. Here's the problem. I fixed it and clicked Done. It is important to note what is now in the recipe list. An analysis of the fired glaze with no LOI. Notice that the numbers in the formula list match those we entered in the formula dialog, although the decimal is moved 2 places. I'll set recipe 1 calculation type to RO unity and recipe 2 to no unity. Remember, we're building a batch from a formula using no unity as in the last session. This will change the formula list to this. Feldspar or nepheline cyanide are good sources of Na2O, and I'll use the latter. I've selected recipe 2, selected the first blank line after the analysis, and entered NEPH in the materials lookup. Now I'll click the Update and then the Supply button. Why did I click the Update button first this time? Because I want to make sure Insight chooses the right material for the line before bringing up the Supply dialog. Remember, the Supply dialog enables you to specify an amount of material based on how much oxide you want to supply from it. In the Supply dialog, I've clicked the Na2O option button and will then click Done. Insight calculates the right amount of nepheline cyanide to supply 0.33 molecules of Na2O. Notice I have the KNaO box unchecked to be able to see the Na2O and K2O separately. However, notice that alumina has been greatly oversupplied. If you use soda feldspar, the same thing will happen. What do? A boron-free, high-sodium, low-alumina material is the answer. But what? A frit. These do exist, and you can find them, and I'll show you where. You can search at the Digital Fire Reference Database to find this type of material. Notice I have level 2 access. I got here by logging in at digitalfire.com homepage and clicking the reference database link. I'll click the material link and then click Search. I have specified I want a material with less than 5% boron and alumina and more than 15% sodium, and then click the search button. This is a very powerful search to find a material of the chemistry you need, especially frits. Notice the first hit, frit 3110. I'll click it. Here's detailed information about it. Now I'll scroll down to the bottom of the page. Notice this section. If Insight did not know about this material, I could use the XML interpretation feature in the materials dialog and paste this in. I could also add this material to my MDT by choosing Update Materials File in the Insight Help menu to download an MDT to which I have added this. Notice I've chosen North America as my starter table and then searched for frit 3110. However, notice that it already is in MDT number 1, that's North America. If it were not, I could check it and click the Add button. Finally, I would click the Generate button, it would be built, and the download link would appear. It happens that frit 3110 is already in the Lessons Materials table. Let's look at it. Remember, I need a boron-free, high-sodium, low-alumina material. This frit fits my requirements, well, almost. It would be nice to have 0 boron, but I'll have to accept very low boron. I'm also going to get a little K2O. That is fine since it's so similar to Na2O. I will get CaO and SiO2 also, but that's perfect, I need them. So let's try it. I use the Supply button to match the Na2O using 132 parts of this frit. Notice that the only overshoot is this little bit of boron. Is that okay? Likely it is. Boron is a pretty neutral melter, and remember, ceramic chemistry is not always an exact science. Testing will tell anyway. However, now we have one of those tricky situations that you often encounter in specialized glazes, the need for specialized materials. I could add feldspar to supply the remaining K2O, but I'll overshoot the SiO2. Feldspars also source a lot of alumina, and I want to supply the alumina from a kaolin to suspend the glaze. I could also supply the total of combined K2O and Na2O from the frit, but that too will oversupply the SiO2 when I add the kaolin. I will need to use pearl ash. I will click the next blank recipe line and supply the K2O using it. Remember, I do that using the Supply button. Perfect. Now the rest of the job is looking pretty much like the last lesson. I'll supply CaO from dolomite, the rest of the MgO from talc, ZnO from zinc oxide, Al2O3 from kaolin, and Fe2O3 from iron oxide. This is the best I can do using this frit. The B2O3 and SiO2 are both slightly oversupplied. Now I'm going to retotal to 100 using Retotal Recipe in the Calc menu. Now I'd like this recipe to show the iron as an added amount and have the rest of the recipe total 100. So I selected the line, clicked the Added checkbox, and updated. Notice the status character to show the added status. Then I retotaled to 100 and got this. All the materials except the iron total 100. Before going on, I will choose Round Amounts in the Calc menu. Actually, let's try it again. I need to be realistic and willing to compromise. I don't have pearl ash, and I've never even seen it. I'm going to need to be satisfied matching the total KNaO as in the last lesson, or satisfying part of the K2O with feldspar and tolerating an overshoot on the SiO2. How would I do that? Notice what I've done here. I've clicked each recipe line and used this button to zero the amounts. I clicked twice to remove the pearl ash line. Then I dragged an empty line from below above the frit and set it at Custer feldspar. How about supplying some of this K2O from the feldspar? To do that, I've clicked the Custer feldspar line I created on the last step and then the Supply button. Then I'll select K2O and manually override the amount needed to 0.07. Why this amount? I'll tell you on the next step. Next, I selected frit 3110 and matched the Na2O. As you can see, the K2O now matches also. How did this happen? I actually experimented in another Insight session with mixtures of feldspar and frit to produce this proportion. Now I just need to click each material line, use the supply button, and specify the correct oxide to supply for each. CaO for dolomite, MgO for talc, ZnO for zinc, and Al2O3 for kaolin. That produces this. The only overshoot is silica, and it is significant. Are there other options? Yes. I could have matched the MgO using the dolomite, and no talc would have been necessary. That would have reduced the SiO2 overshoot somewhat, and produced a small CaO excess. But there is another better option. Nepheline cyanide contains less silica than feldspar. I've replaced the feldspar with it, adjusted the frit until the KNaO is the same. That's why I've set it to 3 decimals. Resupplied all the others, retotaled to 100. This is not bad. The overshoot on the silica is less than half of what it was, and I still have enough kaolin to suspend the glaze. You might say that it is possible to match the formula exactly, except the boron, using the frit and calcined alumina, and here it is. Why worry about the kaolin for suspending? We could just add a gum and suspend and harden the glaze with that. But the problem is you'll turn the glaze slurry into a sticky syrup. It'll have horrible mixing, application, and storage properties. But there's a fundamental lesson here about the need to think on the mineralogical level also. Alumina is not really a mineral, but like a mineral, it has a physical presence that demands attention. Unless you can grind this material for 50 hours in a ball mill, the particles are not going to dissolve into the glaze melt. Alumina is super refractory, and any glaze formula that is derived from an alumina-containing recipe is potentially misleading. I don't know about you, but I get a real buzz out of the juggling act that you can do using the supply button. That one button will really help change your view of materials and see them more as oxide suppliers than white or colored powders. That's the end of this lesson.